Question 5. Let f be the function defined by fs equals cube root of s minus 1. Let g be the function defined by g of s equals e to the negative 2x plus 4. The graphs of f and g intersect at the point 2, 1, which is right here. Let R be the region bounded by the graph f, the x-axis. This one is f, the x-axis right here, and the vertical line as equal to right here, as shown in the figure. So this is the region R. Question A. Evaluate the interval from 1 to 2 of f of x ds. Alright. So basically, the interval from 1 to 2 of f of x ds is the interval from 1 to 2 of this guy right here. And it's gonna be interval from 1 to 2 of x minus 1 raised to the 1/3 ds, right? Now ds, we can rewrite this one as ds minus 1, right? So this guy and this guy agree. We can use the power rule, right? So it's gonna be x minus 1 raised to the 1 over 3 plus 1 over 1 over 3 plus 1 evaluated from 1 to 2, right? So it's gonna be 3 over 4 times x minus 1 power 4 over 3, right? Evaluated from 1 to 2. So it's gonna be 3 over 4 times, substitute 2 for s, it's gonna be 1, right? Substitute 1 for s, it's gonna be 0, right? So the answer must be 3 over 4. Question B. Write but do not evaluate an expression involving one or more intervals that gives the volume of the solid generated when the region R is rotated about the x-axis. We're going to use the disk method, right? It's going to be volume equals pi times the interval from 1 to 2 of f of x altogether square ds, right? And it's going to be pi times the interval from 1 to 2 of cube root of x minus 1 altogether square ds. That's it. Now question C. Write but do not evaluate an expression involving one or more intervals that gives the perimeter of the region R. Alright, so basically perimeter, which means we're gonna add this guy, and this arc length up, right? Now we know that this guy equals 1, right? 2 minus 1 equals 1. This guy equals 1, right? Now we just calculate this one. We're going to use arc length formula, right? So perimeter equals the interval from 1 to 2 square root of 1 plus f prime of x altogether square ds, right? Plus 1 and 1 right here. We need to calculate f prime of x, right? So we have f of x equals cube root of x minus 1. Then this guy can be written as x minus 1 raised to the 1/3, right? So f prime of x equals 1 over 3 times x minus 1 raised to the 1/3 subtract 1, which is negative 2/3, right? So it's gonna be 1 over 3 times x minus 1 raised to the 2/3, right? So we're gonna square this guy f prime of x altogether square. It's gonna be 1 over 9 times x minus 1 raised to the 4/3, right? So we substitute over here, so it's gonna be interval from 1 to 2 square root of 1 plus 1 over 9 times x minus 1 raised to the 4 third dx plus 2, right? Now question D. Evaluate the integral from 2 to infinity of g of x dx equals e to the negative 2x plus 4. So we have the integral from 2 to infinity of e to the negative 2x plus 4 dx, right? It's going to be limit when a approaches infinity of the integral from 2 to a of e to the negative 2x plus 4 dx, right? So it's going to be limit when a approaches infinity of, now remember we have e raised to the ax plus b. When we take antiderivative of this one, it's going to be 1 over a e to the ax plus b plus c. So keep that in mind. A in this situation is negative 2, right? So it could be negative 1 over 2 e to the negative 2x plus 4, right? Evaluated from 2 to a, right? So it's going to be limit when a approaches infinity of negative 1/2 times e raised to the negative 2a plus 4, right? Subtract e raised to the negative 4 plus 4, right? So it could be limit when a approaches infinity of negative 1/2 times e raised to the negative 2a plus 4 minus e raised to by 0 is going to be 1, right? So it's going to be limit when a approaches infinity of negative 1 over 2 times e raised to the 2a minus 4, right? Plus 1 over 2, right? We just distribute this one. When a approaches infinity, this guy approaches infinity. So the whole thing right here approaches 0, right? So it could be 0 plus 1 over 2. It could be 1/2, right? And you see that question 5 in the AP Calculus BC, very simple. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.